Hi guys, welcome to another episode of MrLopezClasses.com. In this episode, this is the second episode of the chapter 3, and we are going to talk about ceramics. It's important in our study of corrosion. Ceramics is basically the result of the oxide of metals. Not only oxide of metals produce ceramics. There are other organic elements that produce ceramics, and right now we are going to talk about that. Ceramics and how important are the ceramics in our business, in the business of corrosion. Why? Because with ceramics you produce protectors. The balloon paint used in the boats is based on ceramics, and you remember the powder coating in some metals is based on ceramics. Yeah. And there are a lot of applications of ceramics in our industry, in the marine industry. We are going to start checking what is the meaning of ceramics. Ceramics are coming from inorganic and organic materials, and they have excellent properties. They are too hard, high strength. They support higher temperature. The melting point is too high, and of course they are the best insulators for electricity and temperature. Okay, ceramics. What is the meaning of ceramics? Advanced ceramics are not generally clay based. The people think that all the ceramics are based on clay, and no, not necessary. They are either based on oxides or non-oxides, or combination of both of them. Let me check what is the meaning of that. The typical oxide, aluminum oxide, copper oxide, iron oxides, those oxides mixed with clay produce excellent ceramics. But there are oxides, non-oxides, like carbides, borides, nitrites, silicas, and they produce excellent ceramics. And those are examples. Silicate of silica, molybdenum silica. Those are excellent examples of ceramics from non-metals. And the typical oxide of aluminum, oxide of iron, oxide of zirconium, oxide of zinc. Those oxides are used to create excellent ceramics. The majority of the ceramics are used in the fabrication of glass, brick, porcelain, cement. But there are other uses for ceramics. Many are metal oxides, and those are compounds of metallic elements with oxygen. And other ones are silicides, borides, carbides, and nitrites. Yeah. This is the main division is silicates and non-silicates. The ceramics are divided in silicate ceramics, bricks, tiles, based on clay, and non-silicate, based on oxides and non-oxide. This is the main difference of ceramics. Ceramic properties. They are in general excellent corrosion resistance. They are too hard, but they are too fragile, easy to break. The majority of the ceramics are also good insulators, and they can support high temperature. Why? Because the higher melting point. The traditional ceramics that we know are used in dishes, are used in roof insulators, in wall tiles, a lot of applications that are commonly used in our neighbor, in your home, in your industry. We are going to analyze the oxides of metal, and we are going to start with the aluminum oxide, one of the most common in our industry. Aluminum oxide, this is the formula of aluminum oxide, is also called alumina. Yeah, and when the metal, everyone knows that if you leave aluminum out in the rain, it rots. Yeah, if the aluminum it rots for a long period of time, it's corroded, and at the end of the day, you have holes, you have destruction of the metal like this. Remember that corrosion is the accumulation of oxidation. Aluminum oxide properties, like ceramics. Alumina is one of the most cost-effective and widely used material in different areas of the engineering. They are used like a electrical insulator, thermal insulator, high voltage insulator, like a seal in O-rings, like the pads on the brake pads. Those elements are fabricated with aluminum oxide, and this is the formula of aluminum oxide. 2 atoms of aluminum per 3 atoms of oxygen. Aluminum oxide, right? And the other commercial name is alumina. Alumina. And now we are going to check about the copper oxide. Remember that I explained in the previous episode that depending with how many electrons is working the metal, when the metal is combined with the oxygen, the metal produces different type of oxides. Iron, copper, iron and aluminum, they interact with oxygen in different ways. Those elements, they have in the last orbit 3 electrons. But depending how they are combined with the oxygen, they produce different type of oxide, and the color of those oxides is different. For example, copper, in this particular case, copper produce, the most commons are copper 1 and copper 2. Copper 1 is Cu2O. This is the formula for copper 1, and this is the formula for copper 2. Copper 1, the color normally is red color, copper 1, and is used in photoelectric cells, and is used in lie detectors. It's a ceramic. It is an excellent superconductor. When the temperature is high, become a good conductor of electricity. And copper 2, the color is black. The color is black. Is used like a pigment. It's used like a pigment, and is used like a abrasive to polish lens, the crystals. I forget to explain that in the first one, in copper 1, is used like a fungicide. Fungicide is very common. Okay, and those are the colors of the copper oxide. Copper oxide turn green when it's exposed to the atmosphere and react with the oxygen. And this is the green color that you found it in the terminals of the battery, the positive post, you remember? The anode is eroded and react with the copper of the cable terminal. You have copper in the cable terminal, and you have lead in the terminal of the battery. Lead with copper have produced a reaction, and the lead is eroded. The lead is eroded, and the copper gain electrons and produce that powder, that green powder accumulated in the positive terminals of the battery. This is oxide of copper. Copper turns green when it's exposed to the environment in combination with oxygen. The major factor that controls the initial rate of the attack on copper is the moisture, the temperature, and the level of pollution. Yeah, those factors affect the copper. Yes, normally the atmosphere affects the copper, oxidize the copper, and produce different colors of copper oxide. Remember, the copper oxide have a three electrons in the last orbit, and if the copper react with oxygen, the copper work with 1 electrons or with 3, creating copper 1 and copper 2. Applications of copper oxide. This is one of the most common applications. Yes, the ballast paint used in your boats is based in copper oxide. It's copper oxide with different pigments to create different colors, but it's copper oxide. This is excellent for boats in fiberglass, for boats in carbon fiber, but it's not good copper oxide copper is no good in aluminum hulls because copper and aluminum are the enemies in the marine environment. For that reason, you need to be careful when you select the bottom paint, the gallon of bottom paint, and you need to be careful that is no, if your boat is in aluminum, you need a bottom paint non-based on a copper oxide, special for aluminum hulls, right? This type of paint, right? The regular bottom paint based on copper oxide is normally used in fiberglass boats. Okay, and now we are going to talk about the iron and the iron oxide. This is the iron ore. As the iron ore is mined out of the ground, its chemical composition is 2 iron atoms bonded with 3 oxygen atoms. You remember that formula? This is the formula that we discovered. Those are the most common iron oxides. It's brown, yellow, and red. Those are the most common iron oxides. Yes, yes, this is the typical oxidation of the iron. In this particular case, is brown when it is exposed to the environment for a long period of time. This is the typical colors, but there are more colors. Iron oxide is a mineral colored black to steel or silver gray, brown, or red with brown, or red, depending of the combination in between the oxygen and the iron. Iron oxide are used as core, like a sand additives, to improve the quality of the sand, and is also used like in exothermic welding rods. Yes, when you weld with arc welding, the electrodes are covered with oxide of iron. Oxide of iron, only to protect the metal, only to protect the conductor. Yeah, those oxide of irons are typically the protection for the rods in arc welding. Iron oxides, yes, there are different types of iron oxides, you see, depending with how many electron is working in the last orbit. There are like 16 type of iron oxides, and they are used like iron ores, pigments, the hemoglobin in your blood, and they are highly used like pigments in paint coatings. In the last chapter of this book, we are going to talk about the different type of coatings and the methods to apply those coatings, and also to change the color of the concrete, the asphalt, that one. There are a lot of applications for iron oxide. Yes, my friends, it's possible that the fiberglass be oxidized. Yes, it's possible. There are different reasons. Basically, the environment, the salinity of the environment affect the fiberglass. The dew accumulated, the moisture accumulated on the fiberglass attack the fiberglass and produce that yellow color over the fiberglass. This process of oxidation, which is similar to rust on metals, take the shiny of the gel coat out and create that yellow color on the surface of the fiberglass. It's possible to remove that oxidation. If it's superficial, it's possible. And I am going to explain the process to remove that oxidation. But before of that, let me explain something. You can oxidize permanent the fiberglass if you bolted the fiberglass with a hardware no appropriated for marine environment, with a regular steel, with a galvanized hardware, and at the end of the day the fiberglass is completely corroded, and at the end of the day the fiberglass is completely delaminated and destroyed. This damage is permanent. It's not possible to repair. You need cut it and you need to repair the fiberglass completely. For that reason, the selection of the appropriate hardware is critical. Remember, we need to use only marine grade bolts, marine grade screws. Those are series 300. You remember 304 or 316, the most common marine grade materials. You remember the type 1810 and 18A. You remember that slide? This is critical. You need to keep in mind. Use always marine grade hardware for bolts, for screws, for washers. All of them should be marine grade. If not, you destroy the fiberglass. At the end of the day, the fiberglass is broken, and you need to repair the fiberglass. You need to cut it and replace that pieces of fiberglass. If the affection of the fiberglass is only in the gel coat, in the surface, it's possible remove that oxidation and return to the original color and polish of the fiberglass. Yes, this is the process. Washing and polishing, you can remove the oxidation. It's too simple. Basically, you need saturate and sponge or brush with a liquid oxidation remover. There are a lot of liquid oxidation remover in the market. All of them are liquid oxidation removal for fiberglass, and the application is too simple. You need to apply on the sponge or on the brush, and you need add it on the area where the fiberglass is a little affected, and after that you need to wash with the water and any type of detergent authorized for fiberglass, and after that you can polish. And you can return to the original color of, and you can buffing, and you return to the original color of the fiberglass. It's not complicated, it's simple. This is a cosmetic. There are a lot of people specialized in detailing, and they use those products, the products for recover the fiberglass. But don't forget, the secret is never install in non-appropriated hardware on the fiberglass structures, because at the end of the day you destroy the material, you affect the fiberglass will be delaminated, and it's easy that the water penetrate and destroy. The selection of the hardware appropriated is critical in our business. You can destroy the boat if you use inappropriate hardware, if you use regular steel bolts, if you use galvanized bolts. We have a great example in the next coming video clips. With Mr. Rodriguez, we received a boat that boat engines is an inboard boat with two Mercruisers, and the stringers were deteriorated because water penetrated in the stringers, because the motor mounts were installed with a galvanized lag bolt. The galvanized bolts were corroded and corrode the fiberglass, and the humidity entered into the stringers and destroyed the stringers. And one engine fall into the second one and destroyed the ball head. And externally, you can see in the structure of the boat externally outside that the stringers, the chassis of the boat is completely destroyed, and the boat is free, is flexible, and the fiberglass, the gel coat is cracked. This is the situation.
Oh, what happened here, Danny?
So here you have, it's bucking because the stringers are, remember the stringers hold the boat straight, and when the stringers go bad, when you hit a wave, the boat flexes.
Can you touch, please?
Yeah, right there.
Oh,
you see.
nice.
And here too.
Oh,
and
this is an indication of what?
The stringers, the hull's starting to flex. And so what happens is when it flexes, the gel coat starts cracking and starts showing where the flex is.
This is exactly the same like in a car when the chassis is broken.
Exactly.
It's exactly the same.
And you have the same identical going on the opposite side.
Okay.
So you know it's buckling.
Okay.
And
This
if
is
you hit it, I think it's already come loose from the
Correct.
from the hull. Yeah, it's delaminated. Well, because all the pressure, this is not designed to hold the whole structure of the boat. So what happens is whatever lamination is just to keep everything together, and the stringer is the main support. And what happens when you have stringers that are bad like this, what happens now, you're putting all that pressure on the lamination, and the lamination is not designed to hold the whole structure.
Danny, this is a great example for our students in order to check a boat when you try to buy a boat.
Absolutely.
This is one of the elements, no?
Yeah, this guy bought this boat 3 years ago.
Yeah, yeah.
After that analysis with Mr. Rodriguez and our helpers, they removed the engines, and we invite an expert in fiberglass in order to prepare a quote for the reparation. And before the expert in fiberglass visited the boat, Mr. Rodriguez and me, we analyzed the situation, and we found this situation.
Question. You asked to the customer about the procedure to remove the deck completely and check the condition of the fuel tanks?
Yeah, he didn't want to do it.
No? Why?
We had to take all the electrical out of the tower because he has a second station up top.
Okay.
So, I mean, probably if I did that, he'd end up like $25,000 worth of work. Right now, he's probably around $10,000–$15,000 worth.
Yeah. And you think that with that amount of money is enough for this reparation?
As far as the $25,000, yeah, it would be.
Okay.
And I would check pressurize the tanks, make sure they're good. The tanks look good. The problem I'm more concerned about is the floors of the tank are rotted or not. There's no way to know.
Correct.
So you would have to take this tower off. You'd have to take the floor completely out in order to inspect that and then move the tanks.
Okay. We are going to do different videos. One of the videos is we are going to cut the stringers and we are going to let the hull completely clean.
Yeah.
No?
Yeah, the first thing they gotta do is clean the hull. Pressure wash this, clean it really good so it's clean. So when you're working on it, you have a clean area to work in, and then they'll start cutting in. Like you said, in the videos you'll see when he's cutting, you'll see the rotted wood.
Correct.
Because you can already see the rotted wood just in that.
It's completely gone.
Yeah.
And we are going to remove the propulsion system, the rudder, the propeller, the
Well, the customer didn't tell him, give me the okay on that yet. He should, but if you notice, he's got a driplet system on one, and he has a regular. Oh, cutlass.
We have bellows in one side and regular stuffing box in the other.
After that, the expert in fiberglass visited the boat, he checked the conditions, and he prepared the estimate.
I'm here with Alvin Miller from Miller Marine. He's going to kind of explain the situation here with the stringers. We took that motors out, you've seen it in the other videos, and we're going to kind of explain what's going on and what does it entail to repair this. So go ahead, Alvin.
All right, first of all, the condition that we see here, bad stringers, and how we determine bad stringers. You tap on it and you listen to the sound where you can tell that the inside, which is the core on the inside, the main string is bad.
Right.
So basically what's holding it is just the outside fiberglass that laminates the outside.
Is that why the boat's buckling on the sides?
Yeah, because there's no strength.
There's no support down the middle of the boat.
No support.
And I see that it's rotted on the inside, like these holes here, you know. So what is it that you got to do now at this point?
At this point, we just got to cut it out, totally erase the bad parts, and then make sure first you have to clean it.
Yeah, you have to clean it first, obviously.
You know,
yeah.
And then
clean it, open it up, and pull all the old wood out, put new wood in there.
Yeah.
Are you gonna put composite or wood?
I'm gonna use wood. Wood is better for strength.
Okay.
It's because of the engine sitting on these. You can't put composite because it's not enough strength for that. For the engine.
Not only that, the lags really won't hold in the composite. I understand that.
So you have to use wood, solid wood.
And how are you gonna make sure the measurement's gonna be the same on both sides?
I'm gonna have to, before I move anything, I have to take the measurements, the height, the width, how long back that I'm gonna go, and there are different steps because this is where you level the engine. So these, you have to have these back.
Right, and I see one just came right out of the fiberglass.
Right, so, which is okay. You can always take it from the other one or measure, make sure it's level. The same thing at the back.
Right.
Basically, you want to put things back the same way that it's there.
So everything lines up properly.
Right.
Correct. So that way we don't have any vibrations and stuff like that.
And you won't have to go through all the different, trying to level it when you're done. You build it back the same way.
Right.
So you have that same level consistency.
So how do you know that it ain't rotted further up where we can't even see?
I believe that there is, but you can't really tell because all of this is wood and it's not open. You have to open it or hit it.
So really you have to open it up to really inspect it to know.
Absolutely.
That's a pretty big job, wouldn't it be? Like console
Oh
and
yeah, it would
it
turn
would.
into a nightmare.
But
Floor.
the thing is, you'd have to take the whole floors up in order to do all that. So
We don't even know if the floors are rotted underneath the gas tank.
I don't think the floor itself is rotted, just where the wood is in the string.
With the engines out, we analyze the engines, the condition of the engines. The engines are completely corroded. This is the situation.
Okay, look at the engine,
Let me raise it up.
fully corroded. Look at the condition of the motor mounts, completely corroded. Silicone here, this is an indication that the stringers are hollow. That's not good. Look at the condition of the block. That's the oil cooler for the steering. The block completely corroded. Completely corroded. This is the problem with the raw water engine. The engine is cooled by raw water. A lot of silicone. This is an indication that the stringers are hollow.
Now the process is the reparation of the stringers. We need cut the stringers completely. Remove the stringers and ball heads. Install new stringers. Normally you have two options: in foam, in wood, or in wood with aluminum on top to reinforce the stringers, and after that you install the motor mounts over the aluminum. That's better. This is my preferred. Some years ago I did a similar project with my students in the class of composite materials. We received a couple of boats completely destroyed. The stringers completely destroyed for the same reason. And after that we cut those stringers. We start to remove the stringers and we clean the hole like this. We use the marks of the original stringers in order to prepare the new ones, like this. And in one boat we did the new stringers with foam, and in the other boat we did the new stringers in wood. Was a nice project. After that we start the process to laminate the stringers with the fiberglass. And this is part of the project with my students, laminating the fiberglass. And when the stringers were completely laminated, they painted with the Mills Coat paint, and after that we prepare the new floor. It's a long process because you need remove everything in the boat. This is too expensive. For that reason, I'm going to explain later in the class of composite materials. Be careful when you buy boats, used boats. The most important part is the condition of the stringers and the condition of the transom. This is a great project. We reinforce the transom with the stringers with a special shape on the stringers, and we laminate the stringers. Nice project. This is part of the project that we are going to do in our class of composite materials. But I bring part of that project only to demonstrate that if you select improperly hardware, no appropriate hardware, you destroy the boat. If additionally you have leaks of current, the process of corrosion is accelerated. And at the end of the day, the boat will be destroyed. The boat will be destroyed. That reparation is, in some cases, more expensive than buy a new boat. For that reason, the majority of the people put the boat on the garage because this is too expensive. Okay? Be careful with that. The life of the boat depends on the condition of the bonding system, the protection. The life of the boat depends on how clean is the boat, how protected is the boat with the proper sacrificial anodes. Yes, my friend, this is the most important part in a boat. In the next coming episode, we are going to advance more and more in the selection of the appropriate sacrificial anodes, the installations, the bonding system, and the identification where is the leak of current. I hope you enjoyed this episode. The next coming episodes are more exciting with more information.